We're now going to learn how to make the relationship between moles and equations. Okay, I'm not going to do any other formula right now. The first thing that we're going to try and learn
Okay.
how to do is the relationship between moles, ratios, and equations. So remember, moles is just a unit for counting. It tells you the amount of a substance.
Okay.
Now, now when you see an equation, what you see is, for
Mm,
example, if you look at this reaction, it's 2Na
okay.
reacting with H2SO4, and they've ended up producing salt and water. Na replaces H, so Na2SO4 would be produced. Na is plus 1, SO4 is minus 2, and plus hydrogen gas, yes, that's going to be released. So that's your full reaction. What does this reaction tell you? This reaction, and it's a balanced reaction. Balanced
Let's do this. There's 2 moles of and there's the same number of moles of everything else, but there's 2 moles of Na. Everything else is 1 mole.
Okay, so that means that 2 moles or two of sodium, if you just have an atom of sodium, two of them are
Mm.
going to react with one molecule of sulfuric acid, and they're going to end up producing one molecule of H2 Na2SO4 and one molecule of H2 gas.
H2.
So it
Yeah.
gives you in what quantity. Now remember that the coefficient is the quantity that is. I mean, you don't have 2 moles, right? Let's make it
Mm.
clear. In
Mm.
any reaction, the so this is always a whole number ratio. It's simply a ratio. Okay? It's not the
Okay.
moles that you have. So it just tells you two sodiums are reacting with one H2SO4. If I have,
Mm.
let's say, if I have 50 moles of sodium, how many H2SO4s would react with?
25.
So according to the ratio, it's going to be 25 moles,
Yeah, 25 moles of the rest of it, man.
and you're going to have 25 moles of this as well, and 25 moles of
H2 gas.
H2 gas as well. So this is the ratio in which the reactants and the products are going to be produced. Uh, w- let's do another equation. For example, if I have aluminium reacting with, let's say, H2SO4, and the reaction is aluminium sulfate is produced, which is Al2, and SO4 thrice. SO4 is minus 2, Al is plus 3, so crisscross plus H2 gas. Now there are three sulfates, so this would be 3. And there are two aluminium, so this would be 2. And the amount of hydrogen gas is going to be 6, so it's going to be 3H2.
6. Yeah.
And so this is the reaction that's happening. What you need to do is you need to, I mean, the coefficients and the ratio in which they're reacting and getting produced, that's already given. What you just need to
Mm.
do is tell me how many, like if you have zero point 0.1, uh, 185 moles of aluminium. So tell me the
Mm.
moles of the other substances that are going to react with it.
Okay. 0.185 divided by 2. So for aluminium, so AlSO43 is going to be 0.0925
Why? You divided
because that's the division 0.185 divided by 2 to get 1 mole. And then
0.0925.
yeah, and let's times that by 3 to get the other 2, which is 0.22775.
Okay, so make it times 3. What do you get?
Two was 0.2775.
0.2775 moles of this and 0.2775
And
moles of
and and for yeah, and for Al2SO43 it was 0.925.
0.0925, right?
Yeah, 0.0925, yeah.
Anyway, so the point is, if you know the moles of one of the substances in the equation,
You can know the most of everything else.
you can pretty much know the moles of all the other substances. Because I'm going to give you
Okay.
another question. Let's say it's 6 NaOH
Okay.
reacting with 3Cl2 molecules, and they end up producing NaClO3, one of them, and 5 NaCls and 3 water molecules. So that's the reaction that's happening. Now tell
Okay.
me what's going to happen if you have I say if you have zero point 0.7, your starting moles are 0.780 moles of NaO,
Okay.
of NaOH.
Okay. 0.78 divided by 2. And then so you got 0.39 of 3Cl.
0.39? Yeah.
Yep. And that's also the same for H2.
Which one?
3H2
It,
gas.
it's the same, right?
Yeah.
What about the others?
0.13 for NaClO.
0.13?
Yep.
Three significant figures, right?
Yep. Okay. And then times that by 5. 0.65 moles for 5 NaC.
The 0.65 moles of. So the main idea right now is you find the moles of one substance, you pretty much find the moles of all the other substances.
Okay.
Now, there's another concept related to this, and that's called a limiting and excess reactant.
Okay.
Now, in the previous reactions, the ones that are on your screen,
Hmm.
the assumption is that they're reacting in exactly the same amount. Like
Hmm.
nothing is getting. I mean, all of them are added in exactly the same amount. You have 0.185 moles of this aluminium, and you have 0.2775 moles of H2SO4, and they're reacting together
Hmm.
to produce those quantities.
Hmm.
So, in reality, you have limiting reactants and excess reactants. What that means is that the quantities that are added, for example, over here, they wouldn't be added in the required ratio. I mean, you're
Okay.
adding it, right? So, I mean, the
Hmm.
required quantity is 0.780 moles, but
Hmm.
by some mistakes, you could actually add more of it, right?
Hmm.
So, starting with 0.780 moles, uh, I mean, let's do another reaction. I have NaOH and I have HCl, and they're reacting together to form NaCl and H2O.
Okay.
I say, in what ratio are they reacting? Is everyone reacting in what ratio?
1, 1, 1, 1.
So, everything is reacting in 1 ratio 1.
Hmm.
And they're going to have pretty much the same exact moles are going to get reacted. All of them would be exactly the same. Now, what's
Hmm.
going to happen if you have 0.85 moles of NaOH and you have 1.20 moles of HCl? I mean, they should have reacted in 1 ratio 1. But
Then you're gonna have the sodium hydroxide gonna run off first, and then there's gonna be excess HCl in it, and it will make the proper thing you want because you have excess HCl.
okay, so how much excess HCl do I have? I think it's 0.35 moles.
Yep, but yep, 25.
Okay, that's more than the required amount. You should have added it. 0.85
Hmm.
according to the ratio would only react with 0.85, not with 1.2 moles. So that means
Hmm.
0.35 moles is in excess and only 0.85 would react.
Hmm.
Achha, so remember the excess reactant, all your calculations are done by the limiting reactant. You always use the limiting reactant. So all calculations are done using moles of. Why not the excess method? Because the excess ingredient is not reacting. Not all of it is reacting. So all calculations are done using moles of limiting reactant.
Okay.
ठीक है, and always remember, ignore excess reactant.
Okay.
ठीक है, ignore excess reactant moles. This 1.2 should not take part in the calculations. Why? Because 1.2 moles is not reacting. A lot
Okay.
less is reacting. So how many moles of NaCl and H2O would you have?
Um, 0.85 moles.
Hmm? Not
0.85 moles.
exactly. So this would be 0.85 moles.
Mm,
This would also be
85 moles.
0.85 moles. ठीक है? So remember this, that the product moles would be derived from the limiting reactant. ठीक है? Not the
Okay.
one that's in excess. So this is known as your limiting reactant, and this is the one that's known to be in excess. Try doing another question. This one was fairly easy. So your question is, like, you have 6Na
Mm,
plus HCl,
mm.
and it forms a what? I mean, this, just one second, this one. No, sorry, Al. Okay, let's say you have Al and HCl reacting together to form AlCl3 plus hydrogen gas is given off. Now, to balance the hydrogen, there would be three of them and two HCls, not two, six HCls, two AlCl3s, two Al. So this is your reaction. Quickly do the
Mm.
calculations. This is 0.15 moles,
Okay.
and the
Let
other
me
one,
do. Let me do.
is 0.95 moles.
Okay. So what do I do?
Find the one that's limiting, and which one is it? Which one is in excess more than the required amount?
Okay. The one that's limited is AL,
Why?
and the one that's in excess because that's less than the HCl because that's more. So that's the excess one, and
Okay.
it's the limiting one because it stops the reaction.
Let me change this just one second. What about if you have 0.40 moles of HCl?
Then still the same. Still the HCl is still the limiting reaction.
Which
So
one?
HCl is still the excess one, and the AL is still the limiting one.
Why is HCl the excess one?
They still got more.
ठीक है. अच्छा, remember, it's not the quantity that matters. I mean, it is more, but
Mm.
excess reactant does not depend whether it's more or less. Whether it's more than the required amount or not. How many moles of HCl should react in the reaction?
Oh, okay, one second. 0.15 times 3. Okay, I just 0.45. Okay, I forgot about that.
Okay, so this is
Point.
going to completely react because you have
Yep.
enough aluminium to react with 0.45, right?
Yep.
So the reaction
So
would be
aluminium,
so the
aluminium
reaction
is in excess.
yeah, so the reaction would be limited by HCl. I mean, HCl is going to stop the reaction. I mean, you have more aluminum than the required amount. Like the
Okay.
aluminum can go on, and it could keep on going if you keep on adding HCl. It's because of HCl that the reaction has finished.
Okay.
And aluminum is the one that's in excess, right?
Yep.
Now I'm going to tell you one shortcut about limiting excess, and that is because it can get confusing which one is in excess, which one, especially when the ratios are like very different, right?
Mm.
So the shortcut is you're given zero point 0.4 moles of this, right?
Mm.
So what you do is divide by the coefficient, which in this case is 6.
Mm.
And this one, the moles that are given to you are 0.15. So what you do is you divide by the coefficient in the equation, which is what? Not the
2.
co. It's 2, right? Which one do you think is the bigger value?
0.15 divided by 2.
TK, so it's the bigger value, right? So that means this is the one that's in excess.
Okay.
Okay, this is what we found out, right?
Yep.
So remember these shortcuts. If you know the moles of all your reactants,
Hmm.
then it's very easy to figure out which one is in excess. The one that's more than the required amount would be you take the moles, divide by the coefficient. Take the moles, divide by the coefficient. Anyone that's giving a bigger number, that's the one that's in excess.
Okay.
Okay, so you don't have to do the ratio thing, etc. You just find this out and you figure out which one is in excess.
Hmm.
Now, your products are going to be, remember, this thing needs to be cancelled out. Excess should not take part in the, I mean, the excess moles should not be used because they're not completely reacting. So
Okay.
find me the moles. These are the moles that you're going to use. Limiting reactant moles always. Find the moles of AlCl3 and H2.
So for for AlCl2, you're gonna 0.13 recurring moles.
How much?
0.13 recurring.
Okay, so it's 0.133.
Okay.
What about H2?
And then 0.2
So it's going to be 0.200
mole.
moles.
Yep.
So both of these are your moles. So remember this trick of figuring out which one is in excess, which one is not in excess. The small,
Okay.
just divide the moles by the coefficient, moles by the coefficient. The one that's coming out to be bigger, that's the one that's in excess. And you never use excess reactant moles in anywhere in the
Okay.
calculations.
Okay.
So now try doing the next question. So you have magnesium hydroxide plus phosphoric acid, and you're going to get Mg3 plus H2O. And we can start 3 magnesium, so there should be 3 magnesiums over here. PO4, they're twice on that side, so there should be 2 PO4s. What else? Hydrogen is, how many hydrogens do you have? You have 6 over here, and you
Mm.
have 2 and then 3 molecules, so that's another 6 hydrogens.
And
And the
there should be
last
6 there.
And the last one would probably be balanced. You can count 6 oxygens plus 8 oxygens, that's 14 oxygens. 8 oxygens plus 6 oxygens, that's also 14 oxygens.
14.
Now it's a
Mm.
base plus acid reaction. I've figured out. I'm going to add the number of particles. Okay, you have 8 times 10 power 23 particles of magnesium hydroxide, and at the
Mm.
same time you have 9 times 10 to the power. Let's make this. I said, let's make it 11 times 10 power 23 particles. First thing, how many moles do they have?
Um, the first one is 1.328 moles. 329.
1 point.
8. 329.
That's that's it. What about phosphoric acid?
And where did you get 1.8 from?
Hmm?
Where did you get 1.83 from?
Which one? Phosphoric acid?
No, for MgO2, why does it say 1.83 moles above it?
I mean, you just said 1.83. How many moles do you have?
At 1.3289. 1.33.
Oh, 1.33 moles. TK myself. So you're getting 1.33 moles, right? What
Hmm.
about the moles of phosphoric acid?
Um, 1.83.
So you're getting 1.8. Which one do you think is the one that's in excess?
The one that has 1.83 moles in.
Why?
Wait, actually no. Go do 1.83 divided by 2. 0.915. 0.915. Okay, because that's got a lot more in.
Like after the division?
It's got 0.915
Yeah.
and
And
the
the
other
other
one
one?
got 0.443 recurring.
So this is the one that's in excess, right?
Yeah,
As I remember this division part, you don't actually have to show it. Okay? That just gives you
yeah,
directly which one is in excess. So
okay.
find the moles of, I mean, you're going to use limiting reactant moles. So find the moles
Mm,
of the products on the other side.
okay. Should I just use 1.33 or should I use a proper whole number?
1.33. Like, yeah, 1.33, use that.
Okay. So it'll be 0.443 of Mg3PO42,
0.44.
3 recurring,
What about the other one?
2.66.
How much?
2.66.
2.66 moles, right? So
Mm,
I'm just going to give you a small homework.
okay.
Uh, let's do ammonia, 3 ammonias plus phosphoric acid, and you're getting ammonium phosphate. So that's the reaction. And what you need to do is you need to find. I'll just write it on the question. This is 1.5 times 10 power 22 particles,
Okay.
atoms. This is 0.85 times 10 to the power 22 molecules. Now, what you need to do is, I'm just going to write it on the equation, find the moles, and then you also have to find limiting in excess. And lastly, find the moles of the product.
Okay.
Right? Okay, try doing this right
How
now.
many?
Hmm?
How many significant figures?
Th- uh, three, and I'll make these three as well. It should be 1.50.
Okay.
This should be 0.850.
Okay.
Okay. If you try and send this, it's just going to take 2-3 minutes. Okay.
Okay.
Chalo. Okay, I'm going to disconnect from here, waiting on WhatsApp with
Wait,
your
wait,
answer.
wait, wait, wait. Wait, wait. I don't have the board link.
I see you don't have this board link. 1 second. I'm sending it on the group.
Okay.
See, I've sent it on the group.
Okay. Thank you very much.
So okay, then take care, Viv.
Okay, Jalafis.
Okay.